so is Gary. Are you there?
Yes, I'm here.
Okay, well, yeah, so while we try to bring Michael back, do you think you're ready to maybe jump in on your presentation?
Yes.
Okay, wonderful. Yeah, so let's do that. We'll continue on with you, and then once Michael rejoins, then he can resume his, finish up his talk. Okay, well, thank you so much, Gary. And so we'll talk about Gateway. So take it away.
Okay. Well, thanks for including me in this, and I'll be speaking, from a system engineering perspective. For I am with the Gateway Systems Engineering and Integration Group, and typically I work integrated spacecraft performance type issues. So trying to solve kind of complex multidiscipline issues, which this is one. I'm not a dust expert, and everything I know about dust I've learned in the past 18 months since I was asked to come up with the Gateway Lunar Dust Mitigation Strategy. So let's go ahead and go to the next chart. This presentation is going to be about where we are in developing that strategy, and then it's really going to focus on what the open questions and needs are for Gateway. So if you go to the next chart, and I do not have many pictures in this presentation because a lot of this is export controlled and not classified, but somewhat sensitive. But I wanted to at least start with a little bit of one orientation slide in case folks aren't that familiar with the Gateway. The Gateway is going to be in a non-rectilinear halo orbit, which is shown on that little picture on the right. Hopefully you can see the Earth and Moon there. And so, we are, these NRHOs are a fairly stable family of orbits that are around the lunar libration points. And of course, the reason we're orbiting there is because it's somewhat inexpensive to maintain the orbit there. It's fairly stable. And then just a couple of things about our orbit. I don't want to give a talk on orbital mechanics, but our paralone, or our closest approach to the moon, is around 1,400 kilometers. And then the farthest approach there is around 70,000 kilometers. The period of that orbit is roughly 1 week. And then the Gateway itself, there's a 2D image of a 3D CAD model there that kind of shows what it's made of. So the Halo module, which is labeled, and the IHAB module, which is labeled, those are the two primary modules where our habitable volume control is. So for dust inside the vehicle, all of those modules have pressurized volume, and the hatches are generally going to be open, for all of those. And so it's those two modules in the center there that are kind of controlling that atmosphere. So they're the ones with the responsibility for filtering out dust, among other things. And so the concept here is that this is to help build a more sustainable lunar program. And so the lunar lander will make multiple visits up and down to the surface and dock to the Gateway. Orion will be the vehicle that brings crews from the Earth to Gateway and takes them home. And then, of course, the airlock is a way to get outside of Gateway to do maintenance on Gateway. And then the logistics module is bringing up the Twinkies and T-shirts and all of the stuff that the crew needs to perform the missions. Okay, so on the next slide, you might wonder, why are we worried about dust if we're not going to get any closer than 1,400 kilometers? There's kind of just a little problem statement, and you've heard other people talk about, some of the perils of interacting with the dust. So, from a Gateway perspective, all our mitigation strategy is to leave as much dust on the moon as possible. But you know, we've learned that zero dust at Gateway is just not feasible. We are going to have some. In fact, we even want some. We do want sample returns going through Gateway. We just don't want it, you know, mucking up our sensitive hardware or getting in the lungs of the crew. And so when I was first asked to come up with this strategy, one thing that was the most obvious to me was that this had to be more of an enterprise level problem. I couldn't work it with Gateway alone. And Michael was alluding to that at the beginning of his talk. So one of the first things we did was we initiated this Dust Mitigation Stakeholders Forum, and that includes, you know, the EVA surface systems, the human lander, the other surface systems, habitats, rovers, the Gateway, Orion, and then of course STMD, where Michael's from as well. He's been a key participant and one of the, as part of the steering group on this forum that I chair. So on the next slide, so this is where the dust, how the dust gets to Gateway. These are the things that we are worried about, and probably the most, you know, understandable and probably the biggest source of the dust will be that's coming up on these human landers. So both external, on the external surfaces, we expect some of that dust to transfer from the surface of the lander to the Gateway. And we expect that to be, you know, a very low velocity dust, but we are worried about that kind of building up over time. And then also, you know, when we open the hatches, the air from the lander is going to interact with the air from the Gateway. And so, you know, we're worried about dust in the cabin air as well. We also expect some ejecta from the lunar lander plume surface interactions. So again, I said we're 1,400 kilometers up. A lot of the early work that's been done by Phil Metzger and others on the plume surface interaction team does show that some of these particles with the large landers we're talking about will reach escape velocity, and so some of those are going to cross our NRHL. In fact, what they're predicting is there'll be like 2 streams of dust that'll cross in different spots in the orbit, and that could go on for as long as 2 weeks. So I mentioned that our orbit period was 1 week, so we can't just avoid these streams with mission planning. We are going to have to deal with that dust as well. And then of course there's the cosmic dust, the interplanetary dust, that some of which comes from the moon, that comes from impacts of meteoroids. And then I just listed the general parameters that we're interested in. And so if we, you know, one thing I'll mention about that is, you know, in addition to how much, you know, dust gets on the Gateway, those last couple of bullets, we're also interested in, you know, how much comes off just through flying through the natural environment and then through induced environments as well. So if we go to the next slide. So this is just an executive summary of a TIM that we held back in November of 2019, and then it has some of the completed progress after that. So at that TIM, we basically formulated an actionable plan to resolve the issue that was brought to our attention at our requirements review that we had been, you know, neglecting dust. And so the focus there was to develop requirements, and we have done that now. We've got a consistent set of requirements across all of the programs. We're currently working on an integrated verification strategy for those requirements. And in addition to that, we've also been completing some initial development test or test for knowledge gap closure. And I think Michael talked a little bit about those, but just some of the key ones are we've been testing the EVA tools to see how much dust we can remove from suits. We've been testing HEPA filters, and there's some more of that, you know, going on now. That's our primary means for filtering the atmosphere. And then also testing on docking seals to see how the simulant is going to affect leak rates in the docking seals. So next slide. So on the next slide is just a list of some of the areas where Gateway still has open questions or needs, and I'm going to talk a little bit more of those on some of the subsequent slides. So we'll just go ahead and go to the next one. Yeah.
We have about a minute left, Gary.
Okay. All right. Let me go through some of these just real quick. Then for verification, we know at the system level we're going to have to do that by analysis, but we want the analysis grounded in test. Next slide. And so some of the things we've got to answer is we have these 30-day time-weighted requirements for crew health, and we've got to figure out how are we going to verify those without running a 30-day test or analysis. And we've got size ranges for the particles that we just pulled out of the Disney, which is the natural environment, but we know that we can probably narrow that range, and we need to figure out what's a reasonable range to test for. Next slide. Let's see, for monitors, we want to be able to distinguish from lunar dust from human dust, and we need to figure out what is the applicable limit for sounding an alert for the crew. Next slide. For the external, this is where the biggest gaps really are. We need to we developed a very simplified transfer dust model, but we've got a lot of simplifying assumptions and that we need to kind of close the ranks on. We need to understand the adhesion properties for the different materials, how dust is removed through natural environments. We need to understand the plume surface ejecta a little bit better, and we've got agreements with HLS. We're working these things together. Next slide.
Okay, I think we're going to have to wrap up here pretty soon.
Okay, let's go ahead and skip this one. I talked a little bit about the development tests. We're trying to make sure that those answer the questions that we need answered. And then let's go ahead and go to the next one. And this is the last one I'll really talk about, is we're trying to get some detectors on the gateway, and we could really use some help with advocacy there. It's difficult because of the integration cost. I started this as a payload, but we need these things kind of dispersed. So I'm looking for, maybe smarter ways to collect some early data on the gateway. And I think that's about it. I think one more slide is just a summary. You can kind of read that. We're trying to get the partners more engaged. I had a kickoff on that just this morning. And some of those other things I believe I've talked about. And so I think the next slide is just a thank you, and that's it. Thank you, Jorge.
Okay, great. Well, thank you, Gary, and I appreciate you having us in after Michael's